This problem involves finding the slope of a tangent line for a parametrically defined curve. So here we have a parametric equation. X is given by t squared plus 2t. Y is 2t cubed minus 6t. And even though we don't know what this graph really looks like, we can still find the slope of the tangent line at t equals 0 without too much trouble. Let's remember our basic formula for the derivative of a parametric equation. If we want to find dy dx, which is a formula for the slope of the tangent line, we can do it as follows. It's dy dt divided by dy dx. Or sorry, dx dt. Let me erase that. dy dt divided by dx dt. I don't really need these brackets, but I'll just put them anyway. What is that going to be for this one? Well, dy dt, let's see, y is right here. Y is equal to 2t cubed minus 6t. I'm going to differentiate that with respect to t. 2 times 3 is 6t squared. My computer is stalling here. 6t squared minus 6 times 1, which is just 6. Let me straighten this line up a bit. And then dx dt, x is t squared plus 2t. We're going to differentiate that with respect to t, so that's easy. It's 2t plus 2. Even though it's not necessary, it would be nice if you'd notice that there's a 2 common everywhere here, so we can factor off a 2. One way to do that, maybe if you're not comfortable, is let's factor a 2 from the top. So we get 3t squared minus 3. And we'll factor a 2 from the bottom. We'll get t plus 1. And then these 2's go away, right? And we could even factor the top more, but yeah, why don't we do that? It's totally not necessary, because all we're going to do is put t to be 0 in there. And when we put 0 in there, we get 0 minus 3 over 0 plus 1, which is negative 3. But it's always good practice to factor things, so let's just keep going. Notice we can factor a 3 out from the top as well. And this is a difference of squares. We can factor that as t minus 1 times t plus 1. And then we notice we even have some canceling here. So we get our derivative to be, in the most simple form, 3 times t minus 1. Now it's easy to find the equation of the tangent line at any value of t. We just replace t, so dy dx when t is equal to 0 is simply going to be 3 times 0 minus 1, which is negative 3. So that's the slope of the tangent line when t is 0. You know, way back here we could have put t equals 0 in there as well, and we would have got negative 6 over 2, which is also negative 3, but I just wanted to take the opportunity to practice a little bit in simplifying expressions. Because most of the time you need to simplify your expression down to the best possible terms. So we just practice that, and then we put in the number that we're looking for to get the slope of the tangent line. And that's all we have to do. So just remember this formula right here. This is the formula for the derivative of a parametric equation.